Okay, gents, we're having a look at projectiles today. It's the first time we're doing it. Just bear in mind that we're doing the starting section of it, the ordinary level section, which is projectiles on a horizontal plane. So here are the things that we need to cover today. First of all, what is a projectile, or what is projectile motion? How we represent it mathematically. You should be able to answer what the range, time of flight, and the maximum height are for a projectile by the end of these video series. And also you should be able to solve projectile questions on a horizontal plane. So we start with the first one. What is projectile motion? So I have two images here on the right, and from these we can see that a particle is projected or fired upwards and over at the same time. The motion of this is a quadratic, so projectile motion is represented as a quadratic function usually, or a quadratic graph. And what's really important to remember here is that 1, gravity only acts vertically, as in vertically down, and 2, we always separate the motion up into what happens horizontally and what happens vertically. And we do this mathematically as well. So, really important, separate the motion of the particle into what happens parallel and perpendicular to the plane, which for us is horizontally and vertically. And second of all, we do this mathematically. Alright, I just want to draw your attention to something there as well. On the bottom diagram, the projectile starts from a height of, I don't know, h, they're calling it delta y there, or y, above the horizontal. So if a particle is fired up like that, it will land at a negative displacement. Just something to keep in mind. We won't worry about it today, but it will come into play later on in the week. Alright, so when we separate these things up into horizontal and vertical motions, it means we need to look at the displacement, velocity and acceleration vertically altogether, horizontally altogether, but we keep the vertical and the horizontal apart. And what you need to remember again is that gravity acts in the y direction, as in downwards only. Alright, so how do we do it mathematically? Well, these are our two formula. S is ut plus a half rt squared and v is equal to u plus at. These are the formula we use. But because we have to look at it horizontally and vertically, we look at them in the x direction and the y direction. So the first formula actually becomes two formula. The first one is in the horizontal direction. So we're going to fill in the displacement or the initial velocity or the acceleration in the horizontal direction. And as you should know, if gravity acts vertically down, the acceleration horizontally is equal to 0. Now, that means that the particle travels at constant speed horizontally. So for every second that goes by, the particle travels the same distance. Vertically, we know gravity acts in that direction and it acts down, so a of y will be minus g. So it gives us that formula. Now, we repeat that for v is equal to u plus at. Again, a of x is 0, and a of y is minus g. And I'd like to draw your attention to the v of x equals u of x. That tells you that the velocity at any time is equal to the initial velocity in the x direction. That means again that the particle is travelling at constant velocity. And if you remember the formula for constant velocity, speed is distance over time, that's actually the s of x formula, and that occurs only in the x direction. So what's important here then are these four formula on the right hand side. So let me get rid of the rest. And this then will tell us how to complete questions. So there are always 3 steps, but the first 2 have to be done before bringing in any information from the question beyond the u of x and the u of y. So we start with finding the u of x and the u of y. We then write down the 4 formula, sub the u of x and the u of y into those 4 formula, and then we apply the conditions to the question. Alright, one last thing just to say before the end of this video. You'll see things like the maximum height and the range in a question. The range is the maximum horizontal distance, and that occurs when the particle is after rising up and falling back down and hitting the ground again. In other words, it's the horizontal distance obtained at the end of the time that the particle has been flying through the air. So if we let the height equal to 0 and get a time, that will give us the time taken for the particle to complete its entire journey, or the time of flight. And then if we use that time, we can sub that into the S of x formula to get the range. So again, to get the range, we get the time of flight by leaving S of y is equal to 0, and then sub that time into the S of x formula. Now for the maximum height. At the maximum height, the velocity in the y direction is equal to 0. So to find the maximum height, we need the time taken to reach the maximum height. Let the v of y formula equal to 0. And when that formula is equal to 0, we get a time, sub that time into S of y for the maximum height. I've covered the last point, the maximum height and the range. They're constant for each type of projectile motion, and really we're looking at the maximum height and range after the whole motion is completed. The displacement and the velocity, however, just bear in mind that they change as time goes by. So I'll pause here and we'll do a few example questions in the next video.